In this video, I'm going to look at running chi-square tests. In the last video, I went through how to choose appropriate tests or reviewed it. I did it quite quickly. And now we're just going to go through and run these tests in SPSS, and I will do the continuous data in a separate video. So I have reformatted this a little bit, and you might reformat it differently, perhaps put all this on the same line, save a bit of white space, that sort of thing. So let's have a first look at this first test that we want to do, and that is between male and female and the different passenger classes. And we can see this trend of fewer women in first class, and I'm not quite sure why that would be. So running this in SPSS, you can use the menu items from your output file. It's just that if you've got several data files open at once, you may accidentally select the wrong data file, or SPSS might, because it will do it automatically based on which one is active. So if you've only got one data file open, it's fine to just use these menu options. So I'm going to go to descriptive stats and cross tabs. Now you can see that I have set this up so that it follows the way that I've set it up in my table, because this makes it a little bit easier to look at the output. Under statistics, I don't need that one. I was just checking something. I need the chi-square test, and then this will give me all the versions of the chi-square test that it thinks it can do for the data you've got, and you will need to choose the appropriate one. And then under cells, this is where we can choose what we want to look at. Now, usually I would want to see the standardized residuals, because this helps show which cells are the most unusual, but you might find it helpful to look at percentages or the expected counts, that sort of thing. Now, what I am intending to do is a test for trend across the three classes, but if we run this test, you'll notice that the test for trend is missing, and it took me a little while to work out what was going on. Hence I had that correlations box ticked, because sometimes just trying to do a couple of other things will give you a clue as to why something's not working. And I think what it is that I actually have sex as a string variable, not a number variable. So I'm going to need to recode this very quickly. And if I go to the data view, it's written as male and female. So recode into a different variable. Sex, I'm just going to call this sex2. If it was male, we'll give it a 1. And if it's female, we'll give it a 2. And I'm just going to remember that in my head and hope I don't forget before I put the codes in. But because I've got the original column, I can always check. So this is where I'm going to quickly put my codes in before I forget. Usually I would write this down somewhere, because I really don't trust myself at all. But as I've got the original column, it's not such a huge deal. So I can quickly go to my data view and check that that's all lining up. Now if I run this again, hopefully it will give me the option that I want. So if you're trying to do something in SPSS and it doesn't work, checking your variable types is a really good place to start. Checking how something is, what type of variable it's labeled as, so checking that this is actually ordinal, not nominal, will also help. All of the other things can stay the same. And now I get the linear by linear association. Now, it was a pretty big difference between the three groups, so I'm not surprised that it's significantly different. And what this means is there is a trend, and there's also a difference between each three of the groups. So if I do a bar chart to explain how that works, and I'm going to put in the passenger class as the x-axis, because I think this will show up the differences most clearly. And I'm going to change this to a percentage out of each passenger class, because I know that the sample sizes are not the same. That feels backwards to me. More males in third class. Is that what I had in? Have I got my labels back to front, or have I got this back to front? So what I'm going to quickly do is put in the original variable there. Okay, so did I go do my codes back to front? I feel like I'm misinterpreting something really obvious here. Okay, so it turns out I had my labels backwards on this table, so it's a really good thing I did those graphs. So this is the female, and this is the male. That was super confusing. If this happens to you, just double check everything. Don't just continue on going, oh, that's weird. I thought it would be something different. Definitely check what it is. So I didn't understand why there was a gender difference in the different classes, and I still don't understand why. It's the opposite now to what I was thinking. So there's a lot more men in third class comparatively to the other classes. So the way the chi-square test is working here is that because we had a significant p-value for the Pearson chi-square test, and this is looking to see, is there a difference between categories, and it doesn't have to follow any particular trend. And the linear by linear association is really looking to see, is there a linear trend up or down? It's basically the same as correlation. So we have both. There is a difference between the categories, and also it follows a trend. So if it had gone first class up here, second class down, and then third class back up again, we might get there as a difference between the categories, but we wouldn't get a significant p-value for the trend. So it's not always the case that both of them will be significant. Now, as they're both 0.000, it really doesn't make a huge amount of difference which one I use here. If we hover over it, you can get all the decimal places if you're interested in them. So that's 5 zeros, I think, if I'm counting properly. It's in either case, it's less than 0.0001. So I'm just going to put in less than 0.0030. That seems like a lot. Probably 2 is enough. So that is our passenger class and gender ratio. Now, if I had the capacity to describe why this was happening, and it may have to do with the mobility of men 100 years ago, and perhaps they had more options for traveling, even if they were poor, than women did. I should think that there'll be some cultural context there. So if you were going to talk about this in a presentation, you might want to tidy up this graph and use this as a PowerPoint slide. I would take out the title there. I might change the default colors. I don't think I like them very much. And get this an appropriate size to put on a PowerPoint slide. So now let's have a look at the age and the passenger class. Now, missing data here is an interesting one. Do we want to include this as part of the test or not? Now, I think actually, because there is so much missing data, that perhaps we should include it, because I think it says something about the record keeping, and I think it's something important that there is so much missing data for the third class. So nearly 30% of the data is missing for third class. And with that much missing data, I don't know that it's sensible to draw any conclusions about the age distribution here and whether or not it's different from the other two. So it might even be that here we don't use a test at all because there's so much missing data. But let's have a look at what this looks like on a graph. So this is where I think I would put the passenger class as the color and then the age distribution here. And I would want to change that label to missing, and I wouldn't have it. So if you watch the video on missing data, I've got 2 versions of it. And here I don't have the -999 in the missing because I want to see it. If I want to ignore it, then I can put it in as a missing data code, but I don't think I do. So I might actually just add a label for that, missing. just because I want to be able to see it because I think it's important. And you can see that there is loads of missing data for third class. So we can run a test here. It's pretty clear that there's a difference, and it's possible that you could run this with and without the missing data. But I think this would be something that you would describe. So I'm going to take out the sex and put in the age categories. And this is where I might, they're all significant again, they're big differences. But this is where I might look at the standardized residuals to see what are the most unusual. And the most unusual number, so I'm looking at the largest standardized residuals, is this missing data proportion. And we could already see, just looking at the numbers, that the proportion of missing data was pretty different for third class. So we've got the biggest difference here between third class and second class. So in this case, if I was going to include the test, I would probably include the Pearson chi-squared test, and you can see that that's a really tiny p-value. And maybe I would run it without the missing data as well. I should think it'll still be significant. And then you need to clarify on your table here about whether or not the missing data was included or excluded from the test. So maybe missing data excluded. I'm going to put in/excluded so you can make a decision about what you want to do. And I'm pretty sure that's going to be significant either way, but we could run that quickly without the missing data just to check. So if we're going to run it without the missing data, I'm going to remove that code and put it in here. And we have both a trend and a difference. But I think that category of the missing data is very important. So I'm going to leave this video here, and then I'll talk about running the test for the continuous data in the next video.